Okay, this is 2.4. This is kind of like baby calculus. We're going from just looking at limits as an isolated thing to seeing how limits relate to the rest of calculus. My goal for you today is I want you to identify the derivative of a function as the limit of the difference quotient, and we're going to talk about what a difference quotient is, and I want you to be able to calculate derivatives. So the average rate of change is something that I hope you've seen before, probably in advanced algebra or maybe in FST or or pre-calculus. The average rate of change is just the slope between 2 points on the curve. So if you take two different points, a comma f of a, the y-coordinate is called f of a, and b comma f of b, if you want to find the average rate of change, you would connect those 2 points with a straight line and just figure out the slope of that straight line. That straight line is called a secant line to the curve. It's one of those weird cases in math where there's another name for, where the word secant is used twice. Secant is also the reciprocal of cosine, but in this instance it is a straight line that connects 2 points on a curve. So in order to find the average rate of change, you would just find the slope between those 2 points. So this I hope you recognize as y2 minus y1 over x2 minus x1. So that's the average rate of change. So here's an example problem with an average rate of change. The way I would do this example problem is, first of all, I would hope that you would pause the video at this point and try it yourself, and then restart after you've tried it so you can make sure that you have the right method. For me, it's important to remember that this is an x interval, so those are both x coordinates, and so I first need to figure out what my 2 points are. So at 4, f of 4 would be 1 over the square root of 4, or 1/2. And then at 9, it would be f of 9 would be 1 over the square root of 9, or 1/3. So if I want to find the slope, I would take 1/3 minus 1/2 over 9 minus 4. And then I need a common denominator if I'm going to subtract. So I would need to find a common denominator of 6. So 2 minus 3 over 6 divided by 5. And then that would be negative 1/6. And if I'm dividing by 5, that's the same thing as multiplying by 1/5. So the slope of my secant line is negative 1/30. And in the equation for a secant line, I really want to encourage you to remember the point-slope form of a line. The point-slope form of a line is just kind of the slope formula rewritten a little bit, but if you know a point, and we know 2 points, we know 4 comma 1/2 and 9 comma 1/3, if you know a slope and a point, it's really easy to write the equation for a secant line. So it'd be y equals negative 1/30, x minus, and we have a couple of different choices. I'm going to say x minus 4 plus 1/2. But I could have written it just as easily with that other point. If I want to point out that if in a calculus test you're ever asked for an equation for a line, you can use any form of the line you like, and I know that you could mess with this and put it in slope-intercept form, but you don't need to. It's an equation for the line, so you're done. Don't do any more to that. The part that's new is the instantaneous rate of change. So the average rate of change is that slope of the secant line. The instantaneous rate of change is, you know what, I just want to talk about what the slope is at A. I don't want to talk about the slope of this straight line. I want to know what the slope of this curve is at A. The way we figure that out is we take a point that's just a little bit away from A, so a little tiny distance away, and we call that H. And we say, well, what if we move that point even closer? So we could move that point so that it's super, super close to the point A. In fact, we could make it so that it's basically the same point. And once it's the same point, the slope of that line now just touches the curve at one point, and at that point it has the same slope as the curve. So the tangent line is the line as h approaches 0, or it's the line that touches the curve at just one point, at a comma f of a. If we wanted to find the slope of that tangent line, we would find the slope between the a plus h point and the a point, so that slope would be, well, the y-coordinate would be f of a plus h minus f of a. So those are the two y-coordinates subtracted, and then in the denominator I would subtract the two x-coordinates, but the x-coordinates would be a plus h minus a, so let's just say h. And this isn't quite right, because h is a tiny, tiny number, and we haven't really said what the number is, but the way we make it right is we use all of the math we've used so far this chapter, and we turn this into a limit problem. So we say, oh, the slope of the tangent line is the slope as the 2 points become infinitely close together. And I really want to point out that this part is called the difference quotient. And as we take that limit as h goes to 0, we find the slope of the tangent line, which is sometimes called the derivative. So let's use that. We're going to do example 1 together. And so we want to find the equation for the tangent line. We want an equation at the given x value. So, oh, that's not right. So then what we're going to do is we're going to find, so this is our function. This is not, sometimes people get confused. This is not the equation for a line. This is a parabola. So this is our function. And we're going to try to find that difference quotient. I'm going to pause. I would recommend that you pause here and try to set it up yourself before you check back. Okay, so what I would do is I would find f of 3 plus h and f of 3 and just figure out what those are. So if I plug 3 plus h into this equation, I'm going to get 3 plus h minus 1 squared plus 1. And I'm going to simplify this as much as I can. So I see that this is 2 plus h squared plus 1, or if I square that out, it's 4 plus 4h plus h squared plus 1, or if I add like terms, it would be h squared plus 4h plus 5, or really you could write it in any order. I just wrote it in standard form. And if I plug 3 in, I get 2 squared plus 1, or 5. So then I set up that difference quotient, so it's going to be f of 3 plus h, which is h squared plus 4h plus 5, minus f of 3, which is 5, all over h, and we're taking the limit of that as h goes to 0. And so then the 5's subtract away, and I can factor an h out of the numerator that's left, so I can take that as h times h plus 4, all over h. And what I notice is that if I plug in 0 at this point, I get 0 divided by 0, which means that I don't have an answer yet. I need to do more work, but these two h's cancel. So now if I plug in 0, I get 4. Remember, 4 is going to be our slope, so when we want to write the equation for the tangent line, we remember that point-slope form of a line, and we say, well, y equals 4 times x minus 3 plus 5. And this time I don't really have a choice about which point I'm going to use. I only have one point because that one point is, the tangent line only touches at one point. I'm going to skip the next example for this video anyway. Oh, I'm going to show you a picture of what that looks like. So remember, this is a parabola with a vertex at 1, 1, and the point 3 comma 5 is on the parabola. And if that tangent line that we just wrote the equation for touches at 3 comma 5 and has a slope of 4, so notice how it is that steep, that's the slope of the curve at that point as well. So that's important to understand what we just did. Alright, so some definitions. The secant line, we drew that before. That's a line that connects two different points on a curve. The tangent line is a line that touches the curve at a single point and has the same slope as the curve at that point. And then the last one is a normal line. The normal line is used sometimes in optics anyway, where you have a lens and you want to figure out the line that's perpendicular to the lens. So the normal line is the line that's perpendicular to the tangent line. If you're ever asked to write an equation for a normal line, what you would do then is you would just do all of the same work that you do to write a tangent line equation, but then remember, if we want to find a perpendicular line, we would use the opposite reciprocal slope. So we do all the same work and then we take the opposite reciprocal before we write the equation for our line. Okay, I'm going to stop here at this point. This is a lot for one video, and you probably have enough information to do a lot of the 2.4 homework.